Right now, as you watch this, you are standing on more sand than you could count in 1,000 lifetimes. Every beach on Earth, every desert, every riverbed, every ocean floor, every grain that's ever slipped between your toes on a summer afternoon. It adds up to a number so large it stops meaning anything. Quintillions. A number with 18 zeros after it. And for almost 50 years, scientists, teachers, and one very famous astronomer have told us the same thing. There are more stars in the universe than all of that sand combined. It's one of the most repeated facts in modern science. You've probably heard it before. Maybe from a documentary, maybe from a teacher, maybe from your kids' science homework. It sounds impossible. It sounds beautiful. It is also not exactly true. What we're about to show you is stranger, and in some ways more unsettling than the version you grew up believing. Because when astronomers actually sat down and did the math, real math, not poetry, the universe gave them an answer nobody expected. And once you see the real numbers, you'll never look at a beach or a night sky the same way again. To understand where this idea came from, we have to go back to 1980 and a man named Carl Sagan. If you're of a certain generation, that name probably brings back a memory. A calm voice, a turtleneck, a television series called Cosmos that brought the universe into American living rooms at a time when most people had never seen Saturn's rings outside of a textbook illustration. Sagan had a gift. He could take something almost too large for the human mind to hold and turn it into a single, unforgettable sentence. And one of his most famous lines was this: "There are more stars in our universe than there are grains of sand on all the beaches of Earth." It wasn't a scientific paper. It wasn't a peer-reviewed calculation. It was a piece of poetry, designed to make ordinary people feel the scale of the cosmos in their bones. And it worked. That single sentence outlived the show. It outlived Sagan himself, who passed away in 1996. It became one of those facts that gets repeated so often by so many people that nobody thinks to question it anymore. But here's a question worth asking. Did anyone ever actually count? Because somebody, somewhere, would have to walk every beach on Earth with a magnifying glass and a notepad. And as far as we know, nobody has volunteered for that job. So scientists did the next best thing. They built models. They estimated the average depth of sand on a typical beach. They measured the width of a single grain, somewhere between the size of a period on this screen and a grain of table salt. And they multiplied that across every coastline on the planet. The number they landed on was staggering. Something in the neighborhood of 7.5 quintillion grains of sand. That's a 7 followed by 18 zeros. Now hold that number in your mind. 7.5 quintillion. We're going to come back to it, because on the other side of this comparison is something even harder to picture. The number of stars in the observable universe. And to understand that number, we don't start with stars at all. We start with sand of a different kind. Because it turns out, the universe has its own beach. and it's far stranger than any shoreline on Earth. In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky that looked, to the naked eye, almost completely empty. A tiny black square, smaller than a grain of sand, held at arm's length. They left the camera's shutter open for 10 consecutive days. What came back changed astronomy forever. That empty patch of sky wasn't empty at all. It was packed, edge to edge, with thousands of galaxies, each one containing hundreds of billions of stars of its own. That image became known as the Hubble Deep Field, and it told scientists something almost impossible to process. If a single, randomly chosen sliver of sky held that many galaxies, then the entire universe must be unimaginably full. By 2016, using updated data and deeper surveys, astronomers revised their estimate. They now believe the observable universe contains somewhere around 2 trillion galaxies. 2 trillion. Each one of those galaxies, on average, holds somewhere between 100 billion and 400 billion stars. Our own galaxy, the Milky Way, falls right in that range. A swirling disk of stars so vast that light, traveling at 670 million miles per hour, still takes over 100,000 years to cross it. Try to picture 100 billion of anything. If you started counting right now, one number every second, no breaks, no sleep, it would take you over 3,000 years to reach 100 billion. And that's just one galaxy. There are 2 trillion of them out there. So when astronomers multiply it out, galaxies times average stars per galaxy, they arrive at a number that dwarfs almost anything else in human experience. Most careful estimates put the total number of stars in the observable universe somewhere between 10 quintillion and 200 sextillion. The range is wide because we genuinely don't have a precise way to count something this large. But even at the conservative end, it's a number built from 22 or 23 zeros. So let's put the two numbers side by side, the way Carl Sagan once did. Sand, 7.5 quintillion grains, give or take, across every beach on Earth. Stars, somewhere between 10 quintillion and 200 sextillion across the observable universe. By that comparison, the stars win, easily. But here's where the story gets complicated, because that's not actually the full comparison Sagan was making, and it's not the full truth either. Because when one astronomer actually sat down, by hand, and tried to verify this for himself, he discovered something that should not have been possible. Years ago, an astronomer decided he wasn't satisfied with estimates. He wanted to actually measure something real. So he did what almost nobody else had bothered to do. He took a small sample of beach sand, about the volume of a sugar cube, and using a magnifying lens, he counted, by hand, exactly how many grains were packed into that tiny space. Then he scaled that number up, across the depth of a typical beach, across the average length of coastline on Earth. And when he compared his result to the best available estimate of stars in the observable universe, he found something nobody expected. The numbers were almost identical. Not stars crushing sand by 1,000 times, not sand winning by a landslide. Roughly even. A near tie between two of the most incomprehensibly large numbers in existence. One built from counting the entire visible cosmos. The other built from counting a single sugar cube of beach. Think about that for a moment. The universe, in all its staggering size, galaxy after galaxy after galaxy, and Earth's beaches are, by some honest estimates, playing in the same league. Which raises an uncomfortable question. If Carl Sagan's beautiful, famous line was meant to make the universe sound infinitely larger than anything on Earth, was he wrong? Not exactly, because there's a detail in the wording that almost everyone forgets. Sagan's original line was specifically about beaches, sand on beaches, not sand in deserts, not sand on ocean floors, not crushed rock, not riverbeds, not the Sahara, not the Gobi, just beaches. And that distinction matters more than you'd think, because deserts alone hold staggeringly more sand than every beach on Earth combined. The Sahara Desert alone is larger than the entire continental United States. Add in the Arabian Desert, the Gobi, the Kalahari, the floor of every ocean on the planet, and the total count of sand grains on Earth explodes past anything a coastline could produce. When researchers expand the count to include all of that, not just beaches, but every grain of sand on the entire planet, the number shifts dramatically. Some estimates suggest Earth's total sand, fully counted, could actually outnumber the stars in the observable universe. Let that sink in. Earth, one small rocky planet, orbiting one ordinary star in one unremarkable corner of one galaxy among 2 trillion, might actually contain more individual grains of sand than there are stars in the entire visible universe. That's the twist nobody tells you about. The famous line isn't false, it's incomplete. And depending on how you count, it might even be backwards. But this is where it gets worse. Because everything we've described so far, every star, every galaxy, all 2 trillion of them, is only a fraction of what's actually out there. Everything we've talked about so far, the 2 trillion galaxies, the hundreds of sextillions of stars, exists inside something astronomers call the observable universe. That phrase sounds like a technicality. It is not. The observable universe is not the entire universe. It is only the portion of space that is close enough for its light to have reached us since the beginning of time. The universe is roughly 13.8 billion years old, so we can only see objects whose light has had enough time to travel here. Beyond that boundary, there is more universe. We just can't see it. We may never see it. Its light hasn't arrived yet, and depending on how the universe is expanding, some of it may never arrive at all. So every star we've counted tonight, every single one of those sextillions, is only the part of the universe close enough to say hello. Everything past that edge is a question mark. Possibly more galaxies, possibly more stars than we've already tried to imagine. We simply don't know, and we may never know. This is where the comparison stops being a fun trivia fact and starts to feel different, almost dizzying. Because we've just spent 20 minutes trying to grasp the idea that Earth's sand might rival the number of stars in everything we can see. And the honest, sobering truth is that everything we can see might be a small fraction of everything that exists. There could be another 2 trillion galaxies just past the edge of our vision. There could be 1,000 times more. There is no way with current science to know. And it isn't just a matter of more stars we haven't found yet. Many of those distant galaxies are moving away from us faster than light itself, carried by the expansion of space. Which means even if intelligent life existed there, we could never reach them, never see them, never know they existed at all.
They're real, somewhere out there, completely and permanently beyond our reach. So here is the uncomfortable version of tonight's story. We started by comparing two huge numbers, sand on Earth and stars in the universe, expecting one tidy answer. Instead, we found out the comparison itself was incomplete on both sides. Earth's sand might be undercounted. The universe's stars are almost certainly undercounted, by an amount nobody can calculate because we can't see the part of the universe we'd need to count. We are standing on a number we can barely estimate, looking up at a number we can never finish. And there's one more piece to this puzzle, the part that turns this from a strange trivia question into something that should genuinely change how you see your own life. Let's bring this back down to Earth, literally. Every grain of sand beneath your feet on a beach was once part of something larger. A mountain, a piece of coral, a fragment of shell, worn down over thousands, sometimes millions of years by water and wind and time, until it became small enough to fit between your toes. Every star in the night sky was forged the same patient way. Clouds of hydrogen gas, drifting through the dark for millions of years, slowly pulled together by gravity until the pressure at their center ignited nuclear fusion and a new light turned on in the universe. Sand takes 1 million years to form. Stars take roughly the same. Different processes, same impossible patience. And here's the part that should genuinely stop you for a moment. The iron in your blood, the calcium in your bones, the oxygen you just breathed in to listen to this sentence. All of it was forged inside stars that lived and died billions of years before our sun even existed.
You are not just looking at the stars when you go outside at night. You are made of their leftover material. So is the sand. So is every grain on every beach on this planet. In a very real sense, the question we started with, are there more stars or more sand, was never really about counting two different things. It was about counting the same thing twice. Stardust that became a sun. Stardust that became a shoreline. So the next time you're standing on a beach, and we mean this literally, not as a metaphor, try this. Pick up a single grain of sand. Just one. Hold it between 2 fingers, small enough to nearly disappear. That single grain represents one star, somewhere out there in the dark, that you will never see, never name, and never visit. Now look down at the sand stretching out in every direction around your feet. Each one of those grains is another star, another sun, possibly another solar system with its own planets, its own moons, its own version of a quiet evening somewhere in the universe. And remember, we've only been counting the stars we can actually see. Carl Sagan never claimed to have the final answer. He gave us a question, wrapped in a beautiful sentence, and let us spend the next 50 years trying to actually answer it. We still haven't. Not completely. Not with certainty. The truth sits somewhere in the space between roughly equal and we genuinely cannot know, which might be the most honest answer science has ever given about anything. And maybe that's the real lesson here. Not a tidy number, not a final word, just the quiet, almost dizzying reminder that we live on a small planet, made of stardust, standing on more sand than we can count, underneath more stars than we will ever see. That's the real story behind one of science's most famous comparisons. Not a simple fact, but an open question that's been quietly rewriting itself for 50 years, and will likely keep rewriting itself long after we're gone. If this kept you wondering, hit subscribe. Astro Odyssey explores questions like this every week.